any evening where I get to talk with someone for whom I have so much respect and drink a glass of wine, I'm a happy girl. Thank you all so much for coming. I appreciate it. I want to start by acknowledging that I'm a nerd, not as much of a nerd as you probably, but I consider myself a nerd. And I've read a few books on physics. So I've read Stephen Hawking's Brief History of Time, of which I understood maybe 50%. And I've read most recently Christopher Mason's Next 500 Years, of which I understood maybe 25%. And Hakeem, yours, Why Do We Exist? I think I understood like 90% of it, which is a compliment and a credit to you, not me. I want to start there, in terms of like, were you setting out with that goal? I know you're, sort of a proud science communicator, and I think the best scientists really are great communicators. Did you set out to make physics accessible to mere mortals like us?
First, thank you guys for coming out tonight. Thank you for being here. And thank you, ma'am, for inviting me, yes. And I have to say, before I answer, once I got into the publishing world and I'm writing a science book, they brought up Stephen Hawking's A Brief History of Time. And in the publishing world, they say that it is the best-selling book that no one has ever read. Yeah, because it was cool to have it. So I made sure to design a really nice cover. So maybe I could get some of those sales.
Looks like a superhero standing on the edge of something. Yeah.
Yeah, I had a great artist. It's not me. I described it and he made it happen. So we worked it together. But I could never have made that on my own. That's my wife. She could do that. She's artistic. I'm not. Sorry to embarrass you. And by the way, today is our anniversary.
Yes, that's right. Happy anniversary.
We've been together for 13.8 billion years. Yeah.
It's a talk and a date.
So, I did. And, I did and I didn't. And what do I mean by that? I don't talk. So, I had a book before this, which is my memoir, and I described my upbringing. And so it was a surprise to a lot of the people that know me, right? So people who knew me publicly, that small, tiny group of humans, knew me from either being, funny and explaining things on science shows on television. He's the nice guy who explains scientific things. Or they knew me from the scientific side of life, right? Which is people who are really just into that stuff, right, would find me. And nobody would have known that my upbringing was from parents who neither one graduated high school. My father dropped out of school when he was 9, my mother at 16. And so my upbringing was incredibly working class and regular, and I went through a lot of working class communities of the South, and I just don't talk that way, right? And so, I like to make fun of my scientific colleagues like the Sagans, the Tysons, the Michio Kakus of the world. I haven't met Sagan, but I know Michio and Neil, and I tell them, they come across like, I'm so intelligent, I talk funny, right? And so in my career, quite often I'll give a public talk, when I was a professor not doing public books, I talk about science of what I'm doing as my research. And people would say to me, oh, thank you for dumbing it down for me. And I would tell them, like, no, you really don't understand. I'm dumb, right? This is just how I talk. This is just how I see it, right? And so, yeah, I wanted the book to be accessible, but it wasn't a stretch for me, right? Nothing had to change. I just had to be myself and talk the way I talk and remove a lot of curse words.
No, it's fantastic, and I really appreciate the way that you use some really interesting examples for some of the concepts that feel like our primate brains could never grasp them, and we'll talk about some of those in a minute. But leaning into more of sort of like, thinking about writing this book, why did you choose this structure? Because you created these 9 realms,
right.
Or you structured it as 9 realms, from sort of like the human realm, the life realm, to the cosmological, to the quantum,
right.
to the temporal. Why that structure?
Yeah, because I had no choice.
Okay.
And I'll tell you what I mean by that, right? So one of the things that I noticed when I began, after you become a scientist, there's all this push to help other people become scientists, get people into STEM, right? So from a young age, I was out there doing that. And, I found that quite often after I talked about, because my research was into cosmology and the origin and evolution of the universe, quite often people would feel that what I was saying about science, what is observed to be true, is in contrast to their other source of the knowledge from where the universe originated, which is typically their faith, right? And the way they would phrase it to me is, well, Hakeem, you said that science says this, but my faith says this. And what I would say to them is, I was like, here's what you're misunderstanding. Science doesn't say anything. Science listens, right? Science asks the universe, what are you? What are you doing? And the universe tells us, right? So the universe told me that it was those 9 realms.
Okay, you jumped ahead because I was going to wait to talk about the intersection between like spirituality and science till the end. But, as I was reading this, I couldn't help but think about the fact I do transcendental meditation.
Yeah.
And they often in that talk about this unified field of consciousness,
Yeah.
right? How we can all touch this unified field of consciousness.
Right.
The other place you hear a lot about that is in the mystical parts of religions.
Yeah.
Around this
Right.
concept that we're all just little manifestations of the same body of consciousness.
That's right.
And you sort of get there when you talk about the quantum field and sort of the experience of electrons getting entangled and everything being possible at once.
Mm-hmm.
And, can you delve a little more into that, sort of this entanglement of spirituality and physics and philosophy? Because, a lot of this borders on the philosophical, and you seem to enjoy it.
Absolutely. Yeah. Absolutely. So, there's 2 topics, if not 3, that I think are really cool and amazing, but the school subjects are horrible. They suck, right? Physics is one of them. History is another, right? You get into history, it's amazing. And what is the study of like where you got to learn the capitals and where, is that geography? That's geography. Yeah, taking a geography class sucks, right? But if you actually travel the world, it's amazing, right? To get to know the places. So, what was the question again?
I don't even know. No, it was really about sort of like
the spiritual,
philosophical, spiritual,
yeah.
physics combination, and
right, yeah. So here's what I was getting at with that is that there are things that the physicists know that hasn't yet made it out to everyday people or into the textbooks that children are learning from. Right, there's still a lot of textbooks are way behind in terms of what the everyday people at the cutting edge are thinking, right? And so one of the concepts that's been at the cutting edge of physics for decades has been this notion of fundamental quantum fields, okay? And this is something that personally, I as a physicist, and I hate to use this phrase, did not believe in. What do I mean by that? There was no experiment that showed this to be fundamentally true. It came out of the mathematics. And so I am, a real empiricist. I'm like Ibn al-Haytham, right? The dude in 1021 who wrote the Book of Optics, right? What we accept as true is what we observe to be true. If we haven't observed it to be true, I don't care how elegant your math is, I ain't accepting it as true, right? So what happens? Physics says that, throughout all of space, there are these fundamental quantum fields. And they are the ultimate true reality, right?
And one of them birthed the Big Bang.
And one of them birthed the Big Bang, that's right. And Einstein said the only thing that's real are these fundamental quantum fields and energy. And we'll unpack that, what that means, right? But I never accepted it. But then July 4th, 2012 happened, and the Higgs boson was discovered, which meant the Higgs field was real. Why did that convince me? Because every other field that we were aware of sort of had a root in a matter particle, right? An electric field, a magnetic field, space-time. They were all associated with matter in some way, and it's where it seemed like the matter was generating them, right? You could give me a charge distribution, I could write down the electric field. Move it, I could tell you the magnetic field that results, right? But then this Higgs field would be something that's just there at all points in space, and that what gives particles their mass. And
they used to call this the God particle.
well, that's a story. I know the dude. He's dead now, Leon Letterman. He called it the goddamn particle because they were always trying to find it and couldn't, right? Goddamn particle, right? But when he wanted to write a book about it, his publisher was like, bro, we are not naming the book that. So they named the book The God Particle, right? I feel like my PhD advisor. He had all these little inside stories. Damn, am I that old? I just had my 59th birthday, so I'm feeling like, oh, that's 60 adjacent. You know, I'm about to be 60. Woo. That's how I felt when I turned 40 and 50. I felt like they were, accomplishments. Now at 60, I'm like, oh, damn.
But according to your book, you are both 1 and 60 and 113 and a million. So
it is not according to my book. It is what the universe has told us.
Okay.
It is not.
Sorry, but back to Higgs.
Yes. So anyway, when you learn physics, everybody has to do the same set of stuff, right? The same problems, the same exercise, the same bits of knowledge as you build knowledge. And at a certain point, you learn that every electron is identical. There's no way you could tell one from the other, right? It is literally impossible. And that comes into a mathematical expression. We talk about these different types of statistics. Bose-Einstein statistics, which gave us Bose-Einstein condensates, right? Fermi-Dirac statistics, which things like electrons obey. But that Fermi-Dirac statistics, which your cell phone wouldn't work if it wasn't true, requires every one of those electrons to be identical, okay? So what does that mean, the fact that they're all identical? That gives us a hint to the true nature of reality, right? And what is the hint? The hint is anytime you see something like that, that means that the thing you're looking at really isn't the thing. You're probably surprised I use the word isn't and not ain't. But yeah, it really ain't the thing. Thank you, sir. Because I'm hilarious. They don't know it. You know it. No one else realizes it. My wife certainly hasn't yet figured it out. All right. The word she uses is corny. But anyway, dad jokes. What can you do? So the thing that is similar that I use as an example in the book is musical notes, right? If you hear a G sharp, it's a G sharp, it's a G sharp, it's a G sharp, right? It doesn't matter if a trumpet makes it, if a harp makes it, if a violin makes it. It's a G sharp. But a G sharp really isn't a thing, right? If you have perfect pitch, you recognize a G sharp as being a G sharp. But G sharp actually doesn't exist. It's a construct. What really exists are the sound and pressure and density waves in the air, right? What really exists is the voice or the instrument that set that thing to vibrating, right? And so the same thing is true of an electron. The electron is the musical note. It is the vibration of the fundamental quantum field that we call the electron field. Energy is the musician that is playing the note, right? So all of these protons and electrons and neutrons that make you up, each of them are a musical note in a fundamental quantum field, right? So that's why I say each of us is a symphony of quantum fields. But what does that mean? What does that mean? Where can you take that? Well, you and me are the same fields. The fields are single entities, right? Every one of us has electrons throughout our bodies. There's only one electron field. We are all manifestations within that same one field. Those quarks each have their separate fundamental quantum fields. And each one of us, every proton and neutron in our body is made up of those quarks, which are all resonances, fundamental frequencies in those quantum fields. So the idea that we are all connected, oh yeah, that's absolutely true. If you take our universe, it is not stars and planets and whatever. It's a handful of fundamental quantum fields. And everything else is manifested through those fields through the action of energy.
Any questions? No, I'm just kidding.
There will be a quiz.
No, I think that part I just find fascinating, and it breathes life into the idea of sort of like, I hurt someone else, I hurt myself, right?
Yeah,
Like we are all made of the same matter, and we're all connected in some way. We're all little mushrooms with the mycelium underneath.
Exactly. The
right?
fundamental quantum fields are mycelium, and we are the mushrooms.
So for those who haven't read the book yet,
Yeah.
why do we exist?
The book does not answer the question. The book poses the question, right? And why do I write the book to pose the question? Because, number one, our way forward, well, first off, physicists don't ask that question. Philosophers ask that question, right? And I say that we've come so far in our understanding of existence that we can ask that question now and really seek the answer, right? Because as humans with imaginations, we're creatures of narrative. We're creatures that make connections. So if you don't have the proper narrative in your mind, right? If you're watching a movie, you can recognize the narrative and see where this is going, right? So one of the things that I ruin for movies, when people watch movies with me, I tell them what's going to happen next, even though I never saw the movie, right? Like, oh, yeah, he did it, right? And so
I'm sorry.
But here's the point, though. Albert Einstein again said it. My hero Albert is that imagination is more important than knowledge. And so we scientists, we haven't come up with anything new since 1998, right? We have been stuck with no new. All we've done is shown that what we think we know, we really do know. But as far as finding out something new that's fundamental, it hasn't happened, all right? And I think that, one of the examples I give is the whale. So let me tell you what I mean by that. When we teach an astronomy class and we start teaching the students about the universe, one thing we point out to them in order to give them the proper perspective is that just like the cell is the fundamental building block of the human body, the galaxy is the fundamental building block of the universe. So I asked myself, what if I took that analogy seriously? And what if I shrank myself down so tiny that my size relative to an average human cell was the same as my size relative to the Milky Way galaxy? And then I went about studying my universe in that shrunken down state the way we study our universe. All right? So we look at galaxies, and when this was first done by Hubble and them, that's a Southern phrase, and them, by Hubble and them, they first created this typing system, right? There are spiral galaxies, there's barred spiral galaxies, there's elliptical galaxies, lenticular galaxies, dwarf galaxies, right? So we would look around and we go, okay, there's bone cells and blood cells and muscle cells and nerve cells. Then they looked interior to those galaxies and recognized the processes and the constituents. There's giant molecular clouds and stars and nebulae, and it has the arms and the nucleus. It has the halo. Well, we would do the same. We would look inside our cells, be like, there's ribosomes and nuclei and mitochondria and Golgi bodies, right? And then we would look and say, hey, well, look, we looked at the galaxies and noticed that they occur in these structures called galaxy clusters and superclusters, and they're connected by these giant filaments that creates this cosmic web. And we would look in our body and see the same thing. But the thing is that after doing all of that studying, we would not know if we were in a whale or an elephant or a OG on the corner.
Dinosaur, you said in the
Yeah, a brontosaurus, right? You would have no idea. You would not understand the context of your existence by studying it from the inside, right? What was the question?
No, I love this. But so basically, our ability to understand the universe is limited because we're always observing from inside.
Exactly.
And the only thing you say in the book, which I totally agree with, and I think is similar to Einstein, the only thing that can carry us beyond that is our imagination.
It is and that's what we're getting at, our imagination, right? Because when if I say to you, hive mind of humanity, we need to move beyond this problem, and the only thing that's going to get us there is our imaginations. Should I say it? Our imaginations? Us Mississippians are known for our proper grammar. So, we Mississippians.
We might say that.
Wait, you from Mississippi? Where are you from? Oh, again, that's the city that don't count. I'm kidding. That's right. Oh, you went to USM? I was there like last month. Yeah. Yeah, yay, homegirl. So, yeah, we country. So, what was the question again we were talking about? Oh, yeah. So I pose the question because to
Thank
get
you.
there, you need a roadmap to existence, right? And so this is the first one humanity has ever produced. That's a joke, y'all. I'm not that into myself. We've produced them over and over. This is the latest one, okay? And I feel like it does give you a perspective. It gives you the modern perspective up to yesterday, literally. There was research in there that came out this year, research results, but it gives you a narrative of the universe across scales and emergence, and it gives you a story of the universe so that now we can all think about it, and it will be on the back of your mind every day, just like it's on the back of my mind every day. And some young fella like sitting back there is going to take humanity to that next step of understanding.
So you mentioned that sort of science hasn't progressed too much, like in recent memory, but there are some really interesting things occurring right now that you touch on in
absolutely.
the book that I didn't know about, so I'm guessing lots of people here may not know about them. NASA's OSIRIS-REx.
Oh, yeah.
The Planet Simulator.
Oh, yeah.
Certainly things, I mean, I think James Webb is in our consciousness, but things that it's doing aren't so well known. And then, of course, your IMAP project.
Oh, yeah.
Do you want to touch on some of those for people? Because I just think they're fascinating.
They're amazing, right?
Why they may not be expanding our aperture, they're proving things.
Exactly. They're proving things. That's right. So one of the things that I go deep into is the recent origin of life experimentation that has been occurring. So there was a burst of experimental work that occurred in the 1950s. And what people know about is the Urey Miller experiment, where they produced some amino acids that very quickly fell apart. They don't tell you that part of the story. But in recent years, they have created far more sophisticated experiments, right? That's what we keep doing. And when you add details and you add dynamics, you get outcomes that you had not before, right? So let me make one thing very clear right now. Origin of life is really super hard. And we've made a lot of progress while still getting nowhere, if that makes sense, right? No living cell has been created by non-living matter. You know, when you get down into the details, it gets super, super, like, how the hell could we do that, right? You're at a loss. But there are bigger, broader strokes that have been satisfied. So I break it down to some fundamental things that are necessary. First, there's the fundamental kinds of molecules, right? There's the proteins, there's the nucleides that are used as information molecules, there are the carbohydrates, there are the lipids, okay? And so the lipids, when you put them in water, they form these spherical vesicles. So the first thing you need for life is something that is going to separate a space away from the rest of the universe so that this reverse thermodynamics can happen. And what do I mean by reverse thermodynamics? Everywhere else in the universe, energy is being dissipated, right? Things are kind of falling apart, places they're growing. But what life does is it concentrates energy and it creates structure inside of this volume, right? And one manifestation of that shows you how potent this process is the world around us. For the most part, we use falling water and dead life to power our society because life has concentrated so much energy. We take it for granted that a gallon of liquid, right, that is made up of some ancient microscopic life forms that have been concentrated has sufficient energy to propel 2 tons, 20 miles at like 50, 60 miles per hour, right? A gallon of liquid can do that. Like, that's crazy when you think about it, right? Just like our cell phones, they're insane, right? Chimpanzees aren't making smartphones. The fact that we as a species are doing this is like nuts. But the fact that gasoline exists is also nuts. What was the question?
I'm loving this. So we were talking
about,
I think you were talking about the Planet Simulator.
Oh, yeah, the Planet Simulator. So you take these lipids, they make these spheres. So the Planet Simulator is an experiment in Ontario, in Canada, and they took the experiment through these wet-dry cycles. And so essentially, here's how these experiments work. Take simple molecules. There are a lot of simple molecules that are super abundant everywhere in the universe. They're made up of 1 or 2 types of atoms, right? Oxygen, O2, hydrogen, H2, ammonia, NH3 or 4, I forget which one. Water, H2O, carbon dioxide, CO2, right? 1 or 2 types of atoms. Take that, methane, CH4, insert energy, you break them apart. Then you allow them to reassemble, right? And they reassemble into these larger atoms that are more complex, but they're more fragile. And so if you let the system mix up these atoms, then they can form these, in a liquid, they can form these larger atoms. But then if you let that liquid dry out on some solid substrate, they could then form really stable large atoms, molecules, right? Combination of atoms. And so they did this over and over. And what they found is after a few weeks, it had produced simple cells, including RNA and amino acids. Right, yeah. Dead as hell. Not alive. Not alive. Not even close.
And this
right?
this came into like our consciousness just before the pandemic. I have a feeling there's a reason it didn't quite hit everyone.
But also, you mentioned Osiris-Rex,
yes.
right? So we've gone, not only the Osiris-Rex mission, there's been two missions, a Japanese one and an American one, and Europe's also involved, that both brought back matter from asteroids and found the components of DNA, right? The nucleide bases, all right? ATCG, they've all been found on bodies just hanging out, right? Meteors, comets. And so, the universe is making this stuff in abundance, the ingredients of life, but not necessarily have we been able to make life. But what we do see is that very early in the Earth's existence, life existed. Our universal common ancestor. So what researchers have done recently, this result came out in 2025, is they looked at the DNA of archaea and bacteria, which together comprise the prokaryotes, right? These simple bag life forms, single cells, right? And what they found was that the earliest life form that was the universal common ancestor to all of these lineages lived around 4.2 billion years ago, about 300 million years after the planet formed, and they had immune systems. They were fighting viruses. So viruses also existed, right? And, that tells me that not only does life get started fast, but newly formed planets may be preferentially the best places for life to form because there's so much abundant energy in terms of heat and one second, in terms of heat and radioactive decay. And now we found on Mars, right, at the end of 2025, the best evidence yet of life on Mars, right? Former life on Mars. You find these unstable configurations, energy configurations, these so-called leopard spots on Mars. And even recently, there's a more recent organic molecule finding on Mars. So, again, I forgot the question, but that's the answer.
Let me pick it up a little bit because, what I took from your book was that simple life is actually maybe more common than we might expect in outer space and on other planets.
Absolutely. I think we will find it in our solar system, and I think it's pretty much everywhere.
But complex life, like us.
Yeah.
Really unusual.
Super unusual. So I actually present an equation similar to the Drake equation. The Drake equation was an equation that was presented to estimate the number of technological civilizations in our galaxy that may be detectable today. And I think that's the wrong question, because I think the right question is how many star systems should have planets with multicellular life, all right? So when you look at multicellular life, I think intelligence is going to occur pretty much every time, but that doesn't mean you're going to get a technological civilization. Right? Out of all the billions of life forms that the universe species that planet Earth has created, only one formed the technological civilization. So my guess is microbial life is present everywhere, even in our own solar system, where you have oceans and energy gradients, because we're all made of the same stuff in our solar system. So under the ice of Europa, I would not be surprised if there was life there. But most oceans are locked under miles of ice or rock. So and if they're not, they're probably under a super thick atmosphere. In our solar system, how many ocean worlds do you guess there are in our solar system? Oceans of water. not water in mineral, locked in rocks and minerals, but actual liquid water, like oceans. 3-2, right? No, the answer is 10. Yeah, and Europa and Ganymede have more ocean water than Earth. What Earth has, a lot of molten metal, right? Inside our outer core is all molten metal. So yeah, we're an ocean world, a world of liquid metal, which is also underappreciated, right? The fact that we live on a damn lava cake, right? We thought it was a big solid rock, but no, right? There's a core that's solid. Then there's a lot of liquid from like 19% of the radius out to about, I think it's something like 54% of the radius. And then, you have the mantle, which is solid but flowing.
So given the likelihood that there's not much other complex life, at least within the immediate vicinity,
right,
maybe we need to obsess less about being invaded and more our capacity to invade? Is that what you're saying?
We are. I always say, we are the advanced alien life forms we're waiting for.
Right.
It's us.
It's us.
Right? They just did it. Artemis 2. Artemis 4 is really going to invade.
I would love to talk about the Big Bang and quantum entanglement, but I feel like I want to make sure we stay on time. Can you share a little bit more about your early path? You mentioned Marvel's Galactus, the world destroyer, at least 3 times in here.
Love me some Galactus.
So how did comic reading create the Hakeem Oluseyi that we know today?
Yes. So for those, so everybody go out and buy my memoir, A Quantum Life, My Unlikely Journey from the Street to the Stars, and buy a copy for your 80 best friends. Buy them for your whole neighborhood. But then again, it's funny. I had I was new to the publishing world, so I had this lunch with my publisher editor, So you normally work with your literary agent, and so my editor told me, he goes, I was talking to her about royalties. She's like, Hakeem, you got a good agent. You don't need to worry about royalties. And I'm like, what do you mean? She's like, because if you have a good agent, you never get royalties. Do you get it? They get you an advance so big, you can never earn out, right? So you got to first, in order to get royalties, the publisher has to get paid back all the money they gave you in advance. Then you start getting new money after you pay that back. But if you have a good agent, they get you so much money up front, you never earn royalties, right? Like the Obamas, they got like 60 million advance. I don't think Michelle sold a lot of books, but 60 million, that's a lot of books. Okay, so.
Comic books.
So one thing you'll see in my memoir is that I had a very violent and neglectful and abusive childhood, all right? And so the message that I got out of that is don't human. Avoid the humans. The humans ain't safe, right? So whereas most humans bond with other humans, I bonded with books. So, my wife and I attended my brother's wedding a couple of years back, and so it's another one of those occasions where I connect with my old community, and there's people that knew me as a child, and they always tell me the same thing about myself, right? They're like, oh, you was a little 4-year-old boy running around with a deep voice, right? And the other thing they said is that no matter what was happening, good or mayhem, you were always somewhere in a corner with a book, right? And so the very first book I remember that had a big impact on me was when I was 7 years old. My mother ordered these books, not off the internet, because that didn't exist, but they had my name in it, my sister's names, and my best friend's names in it, right? And I really loved to read those books. And then my sister, who was 5.5 years older than me, I was in elementary school, she was in middle school, and they had to read Elizabeth Hamilton, is that her name? Mythology is the book. Edith, is it Edith or Elizabeth? Edith Hamilton, that's right. And I devoured that because I love superheroes and stories, and I was a good reader for my age. And so the next year we moved to New Orleans, and I encountered my mother's childhood best friend, a woman named Alice Jean Brown, who just died late last year. And her youngest son was 2 years older than me. His name is Darren Brown, right? Darren grew up to be the second highest ranking African-American in the Navy submarine fleet, right? And so what happened is Darren had the smart guy identity, or so I thought. So I met Darren. I attended his wedding in 2010. And I said, Darren, I've been talking about you for years, man. I always give you credit for making me a smart kid. And Darren looked at me with the biggest shock. He's like, what? He's like, bro, then we inspired each other. Because until you showed up, being smart wasn't cool. And you kind of gave me permission to have that identity, right? But Darren Darren taught me chess when I was 7. He was 9, right? So I'm trying to keep up with him. And, he and I were always into this superhero stuff, right? He really got me into superheroes. The next year, remember, I moved every year as a kid. I don't know if I told you that. I moved every year, and at 9 years old, I go to my father's village in Mississippi. I would have never called it that, but I started working in Africa, and I'm like, yeah, that was a village, right? Dirt roads, super rural. I had to get up in the morning when I was 9 years old and empty the chamber pot after the women used it, make the fire, slop the hogs, feed the chickens, right? Get on the school bus on those bumpy dirt roads, right, where you get bounced up into the air if you're sitting at the back, which was fun. Dangerous, but fun. And so the question again was, oh yeah. So it turns out when I get there, right, everybody's my cousin, and every dude, every young guy, even grown men, they literally have crates of comics, multiple crates of comics. Talk about like, I would just sit there and devour those comics, right? And then lo and behold, I signed up for the Navy when I was 17. And when I went to the Navy, there was this one dude who had the Marvel Universe comics, right? It was a series of comics that told you about every Marvel character, where their powers came from. And there was stuff like, when Bruce Banner becomes the Incredible Hulk, why does that not violate conservation of mass? Oh, because the mass comes from another dimension, right? So this is my true mind stretching. I wasn't into physics yet, right? I knew about Einstein and relativity, but other than that, I didn't know anything, right? And so this was the real, wow, mind stretching ideas. And so up until this day, I was like, why don't they make movies out of this stuff, right? But then they did.
You mentioned one Marvel hero in a book that I'd never heard of who forms his own dimension.
Oh my God. When they created this dude, whoa. The Beyonder? Anybody? Right. I was in the Navy when I discovered the Beyonder. So for those of you who don't know, the Beyonder was his own universe. A conscious universe. Now, we physicists think that the multiverse is real. The universe is popping off universes all the time, right? Never ending, infinite universe. So Will Kenny's book on inflation is titled An Infinity of Worlds, because that's the reality that the universe has told us that it is. So anyway, when you have an infinity of anything, that means that anything is possible. And so Marvel played with that idea and created a universe that itself was conscious. And what happened is the Molecule Men did something shady, created a rip between the universes. The Beyonder realized that there was another universe, came into our universe, and then as he was exploring, he found one planet more interesting than all others. Guess which one? Earth, of course, right?
But it's like he realized he was a dinosaur, right? Right?
A dinosaur?
Well, you're talking about imagine.
Oh, right. Yeah.
Yeah. And he doesn't even realize.
He doesn't even realize the context of his own existence.
Lonely dimension.
He doesn't even know it. You're absolutely right. Yep.
Amazing.
Thank you for that. I didn't. I never made that connection. Yeah.
Do you see humanity becoming a multi-planet species?
I do. Right. It's already happening. Right. Because the moon is a planet, y'all. Whether so when they say Pluto was not a planet, that's not really true, right? What happened is planets were divided into two categories: major planets and minor planets, right? So the moon. Yeah.
A lot of Pluto fans in
here. There are 38 gravitationally rounded bodies. In order to be a planet, major or minor, you have to be spherical, and so that depends on your size, your mass. So if you're made of ice, which many planets like Pluto are, Europa, Enceladus, then you more easily melt and form a sphere. If you're made of rock, then you got to be a bit more massive. But I think that the radius of an ice planet is something like 100-something miles, 180 miles, something like that. Compare that to the Death Star. You guys know the diameter of the Death Star from Star Wars? It is so damn disappointing. 100 miles. Yeah, that ain't a Death Star. That's a death asteroid, right? So they should call it the Blasteroid, right? It's a Blasteroid. It's not a Death Star. It ain't a star or nothing. So anyway, there are 38 gravitationally rounded bodies in our solar system. So 8 of them are major planets, and the remainder are the 30 are minor planets. Did I answer your question that I forgot?
Well,
so
just
long
more
ago?
sort of, are we? It sounds like we are going to become a
Oh, we are going to
multiplanetary
become
species.
multiplanetary species.
Like, what
yeah.
time scale would you put on that? What do we need in order to become that maybe
Yeah.
we don't know today?
Right,
Maybe we know
right.
what we need, but we don't know how to get there.
I think we have most of it already, right? So the first major breakthrough is everything requires energy. And we have so many different ways of creating nuclear energy via fission, and that is ready to go, right? It has a bad name here on Earth, rightfully so. But, since the times of Chernobyl and, the disaster in Japan, there are many other technologies that are safer that exist. And we've also done the first step of fusion energy. And once we get fusion energy to the point of commercialization, there's no stopping us at that point. But the other thing is that, if you're going to make an electronic camera, right, like we have, I was a part of that process starting, at the end of the 20th century. You know what's the hardest camera to make? 100 megapixels? 1,000 megapixels? No, 1 pixel. That's the hardest camera to make. But once you make one, you've already made a gazillion megapixels. All right? You're there. It's just a matter of time and investment, okay? Because it's the first one. And the engineering to get you that one is so hard. Like, if you look at the first transistor, it's way harder than what we do now, right? So, you know what the hardest body to create a permanent presence is going to be? The moon. The one with no atmosphere and dust that nobody talks about. Google it, put it in YouTube. Moon dust. It has these jagged edges, and it has static electricity properties that is stuck to everything. So by the time those astronauts got off the moon's surface, everything was about to fail already. And they dragged it back into the capsule and started making everything there fail, right? So if you solve a permanent base on the moon, which Artemis 4 in 2028 is the first step of creating that infrastructure, Mars is easy. If you solve that problem, Mars is easy. Now, I also work in propulsion, right? So for Mae Jemison's 100-year Starship Symposium, I was the chair of energy and propulsion, right? So I have my own energy company that I'm a part of, my own, fission energy, and my own propulsion technology invention with my graduate students, right? And, getting to Mars is going to get faster and easier. Getting to the moon is going to get faster and easier. Artemis is looking to have a cadence of like a launch every 6 months, right? Access to space is getting easier and easier. So the phase we're in now is space infrastructure building, right? And so that permanent base on the moon, they say they're going to do it, but I want to see it happen, right? If they solve the dust problem, which to me is super tough, then the rest comes a lot easier, and then they're going to need energy, and we're ready to do that. And then there's a policy called ISRU, in situ resource utilization. So you take the minimal stuff there, you take your energy reactors, and then you produce everything you need from what you have locally, right? So the fission company I'm a part of, our vision is powering that process. Right now, they're testing landers and rovers.
Hakeem Oluseyi, why do we exist? And thank you to like such an incredibly smart audience. Cheers to you guys. Applause for you. Thank you.